I'm going to pick up where we left off, which in the first video I did 1 through 6. I'm going to do 7 through 12 in this video. And like I said, the last questions, which are review, I'll put up in the key. Let me know if you have any questions, but I'm not going to put up a video for them. So let's get into problem number 7 here. I'm going to replace cotangent with cosine theta over sine theta. And I'm going to multiply that times sine theta. The two sine thetas will cancel, and all that's left is cosine of theta. Sometimes they're pretty easy, and problem number 7 is a good example of a pretty straightforward simplification. Problem number 8, on the other hand, maybe not as quite as straightforward. What I do see, though, is both of these, and yes, there are two terms here. They're separated by the plus sign. Both of those have a common sine squared theta, so I'm actually going to factor that out. So what's left behind would be 1 plus, whoops, I'm adding extra letters to cotangent there, cotangent squared theta. So let's see, sine squared theta, 1 minus, no, I'm saying it wrong, 1 plus cotangent squared theta is the same thing as cosecant squared theta. So let's see, sine squared theta, cosecant squared theta can be replaced with the reciprocal, which is 1 over sine squared theta, and the signs cancel. Sine squared theta, all of it completely cancels out, divides out, leaving you just 1. All right, and sometimes that happens. All right, problem number 9. So let's see what we've got here. Cosine squared theta minus cotangent squared theta. Well, that's 1 over sine squared theta. There's theta. And so that would be cosecant squared theta. Quick reminder about this one. Cosecant squared theta minus cotangent squared theta. So that was the original polynomial identity of 1 plus cotangent squared theta is equal to, whoops, cosecant squared theta. So if I subtracted cotangent from both sides, I would create this expression equal to 1. So that's why I replaced that whole thing with 1. Sine squared stayed. Reciprocal function is cosecant squared theta. All right, let me slide on over to number 10 here. Number 10, there's a couple ways to do this. The one that's jumping out of my head immediately is I've got 3 terms. So I've got sine squared theta, I've got negative cosine squared theta, sine squared theta, and the denominator of sine squared theta. And all 3 of these have a sine squared in them. So I'm just going to go ahead and cancel those out. So that will leave a 1 there. That'll completely be gone. So I've got 1 minus cosine squared theta, which just then turns into sine squared theta. Remember, this would have been sine squared theta plus cosine squared theta is equal to 1. If I subtract cosine squared theta from both sides, I create this expression equal to sine squared theta. So there's number 10. Let's slide on over to number 11. All right, so I'm going to leave this as 1 over cosine theta minus. So sine theta is going to stay. Tangent is sine theta over cosine theta. So 1 over cosine theta minus, now I'm going to multiply and create sine squared theta over cosine squared theta. Nope, just cosine theta. Say the right thing. Combine them into a single fraction. So 1 minus sine squared theta over cosine theta. In the same way that 1 minus cosine squared theta turned into sine squared theta, 1 minus sine squared theta is going to turn into cosine squared theta. So we've got a single cosine theta in the denominator that can cancel out 1 of the cosine thetas in the numerator, which would leave behind just cosine of theta. So obviously, some of these problems take a little bit of time. And the nice part is, in some cases, there's multiple ways to simplify them. You're going to end up with the same answer at the end, but there may be multiple ways to figure it out. All right, last problem for this page is going to be problem number 12. So let's see what we got here. 1 over tangent of x. Well, 1 over tangent of x is, apparently I can't spell today, so cotangent of x plus tangent of x. So let's see, cotangent x is cosine x over sine x. Tangent of x would be sine x over cosine of x. I don't have a common denominator here, so let's see what happens if I create a common denominator of sine x times cosine of x. So this fraction is missing cosine, so if I multiply the top by cosine, that would create cosine squared x. And if I do the same thing for the second fraction, this is missing the sine x, so sine x times sine x would be sine squared x. Cosine squared x plus sine squared x is 1. So 1 over sine x times cosine of x. I'm going to split this up. I can't create a single ratio, but I can split it up into 2 pieces here and turn this into 1 over sine x times 1 over cosine of x. So 1 over sine is going to be cosecant of x times 1 over cosine is secant of x. So in problem number 12, we can't create a single fraction, but we can take it down to or not a single fraction, a single ratio. But we can take it down to 2 ratios being multiplied together, which is totally fine. So that's problem number 12. That's the end of this video. Let me know if you have